This is our third video in graphing rational functions. Before we start doing this exact problem, I think we need to look at this whole idea on symmetry and being able to recognize what fraction is equivalent to what fraction. I think students have some trouble with that, so I just made up some examples here to look at. Here's a fraction, x plus 3 over 2. I have taken this fraction and I have changed every one of those signs to get negative x minus 3 minus 2. Those are equal. Here's a fraction. I'm going to change every one of the numerator signs and every one of the denominator signs. That's going to go to negative, to positive, changes to negative, goes to positive, which is exactly what this says. So this was equal to the original blue. Take a look at this. Trying to compare these two, that numerator has had a sign change. So I changed that sign, but I did not change that sign. So these two fractions are not equal because we changed some of the signs, but not all of the signs. And that's what you need to look at when you're looking at this symmetry stuff, is checking out how the signs have been changed. Here's another example. 5x minus 7, is it equal to this over here? No, because I did change the minus to a plus here. This got changed to a negative, but this is still a positive 5x. This is still a positive 5x, so there was not an equivalent sign change. Take a look at this one in red. You take a look at it and decide if they are equal or not. What do you think? Well, that was a positive. That was a negative. I changed both of the signs in the numerator, but did I change any signs in the denominator? No. So these are not equal. So hopefully that'll help you with this symmetry stuff. So let's get on into checking out the symmetry. Here was our original function. To do f of negative x, we know that we want to put negative x in place of all of those x's, which is what I've done. Evaluate this, comes out to be a positive x squared. Of course, this is a positive x squared. This stays negative x minus 6. Are these two things equal? And the answer is no, because the only thing that got changed was that sign to that. So these are not equal. Then we have to look at negative f of x. I put my negative in front of the fraction, right smack even in the middle. I take that negative and I choose to distribute it up to the top. And now we're checking out these two. Are these two equal? Well, think about the sign change thing I just went over with you. That was positive. It got changed to negative. That was negative. It got changed to positive. Oh, but that was negative and it didn't get changed, nor did the front x squared. So these two fractions are not equal. So we're looking at another problem where there is no symmetry. Let's get the y-intercept by evaluating f of 0. So we're putting 0 in place of all those x's. We're going to end up with 0 over negative 6, which just equals 0. So we do have a y-intercept. Find the x-intercept by setting the numerator equal to 0 and solving. So x squared equals 0 is going to give me x equals 0 as my x-intercept. Vertical asymptote, we know to take the denominator, set it equal to 0. This has got to be factored. Factors as x plus 3 times x minus 2. Since this product equals 0, you can set each of those equal to 0 and solve, and we end up with x equals negative 3 and x equals 2 as my vertical asymptotes. Horizontal asymptote, we just need to look at the degrees. The degree in the numerator is 2. The degree in the denominator is 2. This is a situation where the degrees are equal, which means we need to now look at those coefficients. And we're just going to take the ratio of those coefficients. Well, 1 over 1 is just 1. Does our graph cross the horizontal asymptote? Well, we're going to set the function equal to the horizontal asymptote and solve. So I can give this a denominator of 1, cross multiply. And I have this. If I subtract x squared from both sides, I now have x minus 6 equals 0. And I finally have an equation that has been solved, x equals 6. That tells me the curve does cross the horizontal asymptote at x equals 6. So that means we're going to have to extend our chart a little further than we ordinarily would. Now, this is a whole lot of stuff we keep going over. You need to memorize what is required to do each step. To find the vertical asymptotes deals with setting the denominator equal to 0. To do the horizontal asymptotes, you need to memorize that chart from a couple videos ago, as well as how to find the x-intercept and the y-intercept. You're not going to be able to do these unless you memorize that stuff. Here's all our information listed out. I've drawn in the asymptotes. I've put our x and y-intercept here at 0. Now, if you've done enough practice of these, then maybe you have a feeling for what's going to happen here. Because of this dot right here, And knowing the fact that we're going to cross the horizontal asymptote out here, then I know this isn't going to cross. So I'm thinking about a little parabola look right here. If there's a parabola here, then usually what you see will be a curve here and a curve here. And the only way we're going to know for sure is to verify with our t-chart. I've done all the arithmetic already. You can stop the video and verify this arithmetic, but let's get this graphed. So we're looking at -5, which is here, up 25/14, which is 1 and 11/14. So that's about here. If I go to -4, that says 8/3, which is 2 2/3. So -4 up 2 2/3. So that's enough to verify to me that we're getting this kind of curve like this. Arithmetic in this little region here, -2 is at -1. -1 is at -1/6, so barely below the axis. +1 is -1/4, so barely below the axis. So here's my idea of the parabola. Remember, I can't get these curves using this tool very well. You can do better with a pencil. So that this is probably going to be over here also. So let's take a look at the arithmetic. 3 is 3/2, which is 1 1/2. 4 is 8/7, which is just a little bit above 1. 6 is actually at 1, which verifies here we knew it was going to cross the asymptote at x equals 6. So we have a 1 here. And 7 is 49/50. That's just a smidge below that asymptote. So what's happening here is it's coming along here, and it's going to cross that asymptote, but then it's going to continue running very close to the asymptote on that side. Last example of this type, f of x equals x squared over x squared minus 9. So let's go to this page here, do f of -x, plug -x into both of these, and we get x squared over x squared minus 9. Finally, we get something that is the same. Since f of x equals f of -x, that tells us we have y-axis symmetry. As soon as you know you have y-axis symmetry, there is no reason to check for origin symmetry. It cannot have both. So we're into y-intercept, plugging f of 0, put 0 in each of these. I have 0 over -9, which is 0. X-intercept, set the numerator equal to 0 and solve. Not much to solve there. You get x equals 0 for your x-intercept. Find your vertical asymptotes by setting the denominator equal to 0 and solve. This is the difference of two squares, and this is how it factors. So we get x equals 3, x equals -3 for the vertical asymptotes. Horizontal asymptote is a matter of looking at the degrees. Since both of these are x squareds, we're looking at the coefficients, which are both 1. So it's just the ratio of 1 over 1, which is just 1. Does it cross the horizontal asymptote? Set the function equal to the horizontal asymptote and solve. Here's the function equal to the horizontal asymptote of 1. I'm giving this a denominator of 1, and then I'll just cross multiply. I have this equation. To solve that, I would subtract x squared from both sides, which leaves me with -9 equals 0. That's not true. That tells me that the curve does not cross the horizontal asymptote. So now let's put everything together on the graph. There is symmetry to the y-axis. Here's our intercepts, asymptotes, etc. I've already drawn the asymptotes in. Here is the dot for our x and our y-intercept, which happen to be the same dot. Now, why does the symmetry thing help me? It's just really a time saver. It's going to tell me that whatever happens with this curve, because it's symmetrical to the y-axis, whatever the picture looks like on this side of the y-axis, it's identical to that side on the y-axis. So really, it's just going to save me a little bit of time as far as my t-chart goes. So I'm still thinking, because this is here, I know that my curve does not cross the horizontal asymptote, that I'm going to get a parabola. And we know when you get the parabola in that region, you get your curves in these opposite regions here. So let's do the arithmetic. -5 gives me 25/16, which is about here. -4 is 16/7, which is 2 2/7, so that's up here. And that's enough to give me this curve. Having a hard time drawing it. -2 is down at -4/5, which is about here. -1 is -1/8. And notice I quit doing the chart because whatever happened over here, it's identical mirror image over here. So I know without doing any arithmetic or anything, this has got to look like this. These are identical on the y-axis. Same thing, this curve is going to look exactly like that curve. You could take time and do the arithmetic on this if you wanted, but you're going to get these exact same values. That's the benefit of knowing you have symmetry.